happy to introduce Open Infra Day's spotlight sponsor, actually, Lightbits Labs, Sagy Volkov, distinguished technical evangelist. And he will be talking about optimizing your platform architecture for VMs in OpenStack and OpenShift.
All right. Ooh, this is loud. I have to speak very low. All right, so hi everyone. We got 10 minutes to introduce you to Lightbits. So I'll try to make it really fast. Lightbits Lab is the company. Lightbits is a storage. It's a software-defined storage solution. And it's basically built on a foundation of 3 things. The first being NVMe over TCP. NVMe over TCP is a protocol that we invented probably about 7-8 years ago and donated it into the Linux community, let's call it a network community as well. And it's basically the method of running NVMe commands over TCP, over the TCP stack. It's part of the Linux kernel since 4.10. And so on pretty much any Linux distribution that you're using today, you already have the kernel model for it. We invented the protocol. The key about Lightbits is that we wrote our software for storage to utilize NVMe TCP to the max. Other storage providers today are also providing NVMe TCP access into the storage. The key difference is what you do below the network stack at the target level. The other, I guess, part of our pillars is that we wrote our own flash translation layer, which exists on any of the targets that run our software. What it basically means is that we know how to utilize better SSDs, how to enhance their lifespan or life cycle, and how to make sure when writes are occurring that they are only written into the right and best areas on the non-devices. And the third pillar is clustering. So this software runs on any x86 server. All you need is servers with NVMe SSDs in them and network cards on these. And we will cluster everything together and represent all the capacity of all the SSDs as if it's one large logical chunk of storage. This is basically how it looks. Explain a little bit about NVMe over TCP. Each client, whether it will be bare metals or OpenStack or Kubernetes, are just using the NVMe over TCP protocol to access the targets, and they are completely aware of where the targets are, new targets that are being added. Everything can be done on the fly. We support, again, because it's over TCP, if you want to do bonding, anything that you want to create over the usage of the TCP layer, you can do it. We don't really care about the type of network cards, type of switches, any sorts of flags that you create along the way. That's a very, very detailed, I guess, explanation of what actually runs on the target. And in very short, our backend processes are the ones that are doing the flash translation layer. We're also doing local erasure coding at the target level. So you are protected from a failure of an SSD. And the encryption that we're doing is also being done at that portion. Front end is where we look at all the traffic that is coming from all the clients, aggregating writes that needs to be done, pushing them into the right place. Also replication that is being done at the volume level is being done from front end to front end, basically. one of the key things in Lightbits is that you can actually decide the number of replicas that you want a volume to have. So it can be either 1, 2, or 3 replicas. When you create a volume, you basically decide on that. This is kind of a very messy and massive slide on where and what we support and run. So we literally have customers. Some of them are running in cloud. A lot of them are running on-prem. Platforms that are using the storage. We are the first NVMe over TCP driver that was created for VMware. No, it's not a welcome name in this conference, maybe. But we have a CSI driver pretty much from day one of the company. Most of our customers are running Kubernetes. Then some of them are running also OpenStack. In terms of the application themselves, most of the times we don't actually know what the customers are running. But from the big ones, we know a lot of it is leaning towards databases or any kind of IO-intensive applications. These are some performance numbers. On the right side, these are IOPS. What you're seeing is actually 3 servers of Lightbits. Each of them has 12 SSDs. And you can see that IOPS in terms of read-only 4K, about 14 million was done from just 3 servers. That gives you roughly 4-point-something million per target. If you need more, you can just add more targets into the Lightbits cluster. You can also see on the left side some samples of latency numbers that we get. Of course, lower on the IOPS, but you can see also almost 4 million 4K reads with 99 percentile of, 292, which is really impressive. And I got 90 seconds. This is some performance numbers comparing Ceph using OpenStack. What you're seeing is basically VMs that are running inside, several VMs that are running on several OpenStack clients, all utilizing a 3 nodes Lightbits cluster. And you can see with the one OpenStack client, the number of IOPS, it starts to increase about 4.2 million from 4 OpenStack clients. Pretty much stays over there. We need more IOPS. We'll just add more targets to the Lightbits side. And I think this is also a comparison that was done on via a third party, trying to understand the impact of using Lightbits storage together with a flash translation layer, comparing QLC and TLC media SSDs. And basically showing that even with the slower media like QLC, we still get the very good performance because of the flash translation layer. It's also a comparison between Lightbits and Ceph. There's a big gap. And that's it. I don't know if anyone has any questions. You can ask now or just come and talk with us. And we also have a table right after the rack space table outside. Thank you.